can you solve this geometry challenge? Here's the question. Alright, given these 4 congruent squares and these 2 blue segments. Now, if we draw these 2 blue segments, we create an angle called theta. Now, the question is, what is the angle of this theta? You can pause this video if you want to give this problem a try. And now, let's answer this question together. But before that, before we move on to the solution, here is the answer to this question. Angle theta measures exactly 45 degrees. Now, surprisingly, it is 45 degrees. So the question is, what is the solution? Or is there a shortcut for this kind of problem? Now, here's my solution. At the end, I will provide a shortcut. Alright, so let's answer this question together. Now, to answer this question, let's call this angle must be angle alpha. And this angle right here, let's call this as beta. Alright. Now, take note, this angle is theta, and this angle right here, since it is a vertical angle, this is also equal to theta. Now, using the remote exterior angle theorem, we can say that angle alpha plus angle theta must be equal to angle beta. Now, we want angle theta. So what we're going to do is to subtract alpha on both sides. So theta must be equal to beta minus alpha. Next, what we're going to do is to take the tangent on both sides. Now, why we use tangent? Because we will use this identity that says if we have tangent of a minus b, it is equivalent to tangent of a minus tangent of b all over 1 plus tangent of a multiplied by tangent of b. Here is, this a represents beta and this b represents alpha. So tangent of beta minus alpha can be written as follows. We have tangent beta minus tangent alpha all over 1 plus tangent beta multiplied by tangent alpha. So now, our goal is to solve for the value of tangent alpha and tangent beta. Now, without the loss of generality, let's have the side length of the square be equal to 1. So all of this side must be equal to 1. Alright, now let's start solving for tangent alpha. Now we know tangent must be equal to tangent x must be equal to the opposite side. The opposite side all over its adjacent side. So tangent alpha must be equal to 1 over 1 plus 1 plus 1, or simply equal to 3. So tangent alpha must be equal to 1/3. Now, how about tangent of beta? Tangent of beta, the opposite side is 1 plus 1, or simply equal to 2, all over 1, or simply 2. So tangent beta equals to 2. Now, let's replace all tangent of beta as 2. Alright. And then, all tangent of alpha must be equal to 1/3. So we have tangent theta must be equal to 2 minus 1/3 all over 1 plus 2 times 1/3. Now, 2 minus 1/3, this will give us 5 over 3. And then on the denominator, 2 times 1/3, this is just 2 over 3. And now 1 plus 2 over 3, this is just 5 over 3. Now, surprisingly, 5 over 3 over 5 over 3 will give us a value of 1. Now, to get the value of angle theta, let's take the arctangent on both sides. So, theta must be equal to arctangent of 1. And we know arctangent of 1 must be equal to 45 degrees. Therefore, angle theta must be equal to 45 degrees. And that is the answer. Now, is there a shortcut for this kind of problem? Yes, there's a shortcut. Alright, here's the shortcut. What we're going to do is to draw a circle centered at this point. if we do that, we get something like this. Now, surprisingly, the intersection of this blue segment must be in the circumference of the circle. Now, the proof that the intersection of these two blue segments is in the circumference of the circle is your exercise. So, if you have a proof, just leave on the comment section down below. All right. So, let's continue. We know this angle is 90 degrees, of course. And using the central angle theorem, we know that this arc right here must be 90 degrees or the same as the central angle. And this angle, theta, is called the inscribed angle. Therefore, using inscribed angle theorem, this angle must be half of its intercepted arc. And the intercepted arc must be 90 degrees, so half of 90 degrees must be equal to 45 degrees. And that is our answer. And as always, we are done.